Hey there, it's good to see you again. In chapters 1 and chapter 2, we talked about some of the more fundamental aspects of data visualization. In chapter 1, we talked about white space and eye tracking. And then in chapter 2, we touched on color. We explored color theory, some of the basic concepts, and then we looked at gradients versus segmented color. We talked about how using color in different ways can be a great tool to communicate our message more effectively. We said that color is like the tone of our voice. In today's chapter, we'll expand on some of that, but we'll also take a look at some of the do's and don'ts of data visualizations. And then we'll look at some of the more common data visualization types and their use. And we'll explore some of the ones that you should be avoiding at all costs. In addition to this, we'll touch a little bit on some tips and hints on how to prepare a data visualization presentation or items that can make your data visualization a little bit better. So as usual, why don't we just jump over to my computer and then we can take it over from there. All right, let's get started with chapter 3. What is wrong with this graph? Well, let's look at some of the positives. We have a title and a subtitle, and they're both descriptive. They both give me information that is good for me. We also have a legend here, and the legend actually here is very clear. It tells me, which ones are no and which ones are yes. This is a categorical graph, and as a categorical graph, I know that I'm going to have two segments. So, I think the bars are a good width, but what can we point out that is not that good? Well, aesthetically, we can say, well, it's not that good that we have no space between the two bars. We ideally want to have some white space there to separate the two. Now, as far as having white space around the graph, we are doing good. This is good. But we could do better with the design a little bit. But the main issue that I have with this graph is not really as much as the design as it is the use of color. Now, what we're saying here is that more females have a positive diagnosis than male. Now, when we look at this graph, we can see the female number is higher here than the male number, right? For the positive diagnosis, which is the yes. But the problem is a diagnosis of asthma tends to be seen as a negative, something that is not good news, right? So why are we using green in that sense? Green conveys a positive message. Red conveys a negative message in our brains. So when we say this, it will be confusing for our viewers. A good segment of our viewers might see this and think that this right here is referring to the positive diagnosis, and another segment might think that this is the positive diagnosis because this is a red number or a red color. Now, here's the other problem. If you have bright green and bright red, and then you have these labels right here, this is red inside the green and this is green inside the red, and the same thing happens over here. If you have that, what happens is about 8% of the population of males are colorblind to red and green. So what happens if you're in a group of 13 people? Well, there's a likelihood that at least one of them is going to be colorblind to these colors. And if your group is, say, 50, then you're going to have at least 4 of them that are going to be confused with this graph. What if those are one of those is one of your main stakeholders? What if one of those is your CEO? So you need to take into account the fact that there are people that are blind to the difference between these two colors. Accessibility is important when you're designing data visualization. What about monochrome print media? What if somebody took a picture of this slide on your screen and decided to print it into tomorrow's newspaper? And they have breaking news, more females have a positive diagnosis than males. And then when they go print it, they run into this situation right here. When this prints, you can't tell which one is no and which one is yes. And you can't even see the labels inside this. Why? Because this the level of brightness inside this green and this red is the exact same, even though the color hue is different. So you need to be aware of some of these things with every data visualization that you create. Now, what is wrong with this one? Again, we have a good title, we have a good subtitle, we have a legend that tells us what each line represents. And so this graph says more female daily smokers have asthma than male daily smokers. And then we see categories here, and we look at never smoked, we see ex-smoker, and we see daily smokers. So clearly we're focused on this category right here. So when we follow the lines and we see that this orange one right here is females, and then we follow the line and we see the males is here, we can see that our header and our subtitle are true. More female daily smokers have asthma than male daily smokers. So is there anything wrong with this graph? So yes, there is something wrong. What's wrong with this graph? What do we associate with continuous lines? Well, with continuous lines, we associate continuous data. And more clearly, with line graphs, we associate trends over time. This is not a trend over time. These are categories. And remember, when we talked about the different types that we use, we said that when we are looking at continuous data, over time we use line graphs because they immediately represent time data series. But when we're looking at categorical data, we prefer to use column or bar graphs. So that is what is wrong with this graph. Now, if we start to look at the many different types of graph that we have at our disposal, the first one and the most common types of graphs are the bar and column graphs. So columns are the ones that go vertical, like these ones, and then bars are the ones that go horizontal, like these ones. So these are used for categorical data. So in this case, we can see it's truly the same data. We have the categories here, never smoked, and then I don't know, the other categories right behind. But this is broken down in categories, and it's a great way for us to separate our data into segments. Now, horizontal bar graphs are good when we have long labels like this. If the even labels that are longer than this, if the label is too long and it's hard to align it in your x-axis in your column graph, just flip it, make it a horizontal bar graph, and then you'll have plenty of room to accommodate your labels. Now, column graphs and bar graphs can be stacked, and stacking them would allow you to send a different type of message. Remember when we created this one that we talked about stacking this, and this allowed us to focus on the proportion of data compared to the 100% of the values of that category. And that's why we chose a stack column graph. This is the line graph, and we worked through this exercise in chapter 2. In chapter 2, we looked at this graph and we said that line charts are used for trends over time or time series data. And this is a perfect example right here. We can see the years here increasing, and then we can see the data that corresponds to those years. So this is a perfect use of a line chart. Now, what happens when we have too many lines? We will have too many colors, and this can be a serious problem. If you have more than 5 or 6 different important elements in your graph of your data time series, you can choose a different type of presentation of this data rather than a line graph. Because once you have more than 5 or 6 lines, it becomes very confusing for your viewer to understand the message. Now you can do something like this, where you can select data that is sort of irrelevant to what you're communicating, and annotate it. Annotating is perfect. It's a great practice. Now, we also mentioned that you never start your y-axis on anything other than 0. But then we added an asterisk, right? Now, that asterisk is a very, very, very tiny asterisk because the exceptions have to be very, very rare. If you can accommodate your data to display in a way that fits well and it can be displayed okay, then you stick to having a 0 for your y-axis. The only exception that I will make, and I'm very hesitant, but the only exception that I will make is if I'm selecting data and I will indicate that that data is labeled very clearly. If I label that very clearly, or if I include the axis here and I show very clearly that that axis doesn't start at 0, then that can help me communicate my message. But other than that, you should always start at 0. And again, use annotation. Notice here the use of color on these labels right here to match the lines that we use, right? So that way it's clearly understood. So line graphs are great to communicate data over time. Now we can look at pie or donut charts. The first thing that I will caution you about is that these are not very helpful. Pie charts should be limited to no more than 3 or 4 segments. More segments than that and it becomes confusing. Sometimes you have slices that are very small and it's very hard to tell between the 2 slices. So limit the use of pie charts to only data where you have less than 3 or 4 categories. Now, if you end up with a pie chart for whatever reason and you have a very small tiny slice that is almost negligible, that is hard to see, filter that out and add a note to the pie chart, or try to hide it in a way that is less confusing. 3D is very deceiving. Avoid it at all costs. And what do I mean by that? Well, take a look at this graph. Let's pick a different color here and let's look at this graph. This slice right here, it goes from here all the way to here, and it's 14.65%. But this slice right here is 18.8%. Yet this one looks a lot bigger because this is tilted. 3D in graphs is highly deceiving. Avoid it. Never use it. It's not good. It's not recommended. It's just awful. And it looks pretty bad anyway. Heat maps. Heat maps can be a great tool. They can quickly highlight potential issues in our data. The moment we look at a heat map, we can immediately tell where our biggest issues are, right? But color can be overwhelming. If we have 6, 7, 8, 9, 10 different shades, if your colors are very bright, well, heat maps can be confusing. Instead, keep it simple. Add different shades of color so that when somebody looks at the data, they can know that color represents intensity. You don't have to reinvent the wheel, just follow simple principles of keeping things simple. Scatter plots. Scatter plots are great to show relationship between 2 or more numerical values in a data set, in a population or a data set. Now, this is great because, for example, if you have a large set of data and you have multiple data points, you can make a comparison between the different categories within that data. In this case, we're looking at the peak flow of air by age for patients according to their smoking habits. We color the ones that are on non-smokers, and then the ones that are ex-smokers and the ones that are current smokers. A scatter plot allows us to be able to separate those categories into different colors, and sometimes you can use different shapes. And then we added an average for all the pink ones, an average for all the orange ones, and an average for all the cyan ones. What that does is allows us to see the spectrum of data within those values. So now we can see that even though we have data here that is mixed, the average for the current smokers is much lower than the average for the ex-smokers, than the average for the non-smokers. Also notice that a scatter plot can help us identify outliers. As great as scatter plots can be careful with its use because they're not very intuitive for people that are not familiar with them. They're a great tool, but sometimes you want to communicate a message very quickly, and somebody that's not familiar with how these are set up will not make sense of it right away. Box and whisker plots. Now these are great graphs. If you have data and you want to understand the different quartiles of that data in each category, and say you also want to understand how the average of your data sits against the entire data set or against particular quartiles, the box plot is a wonderful graph for that. Now, the main feature that it has is that very easily you can compare the median and the quartiles and potential outliers. So let me illustrate that for you. These are the values right here for all the current smokers. So these values represent all the values for the peak flow of air. This will be 0 and this will be 100. Between here and here, you have your first quartile. From 0 to 24.9% is here. Then from 25 to 50, just to make it easy to explain, from 50 to 75, and then from 75 to 100. So in addition to that, you have a line that goes across, and that line will be the average of your data. So this helps us understand if our data is skewed. If our average is lower here and closer to the 75th percent, we can see that our data is skewed to one side. If we plotted this on a bell curve, we will see an uneven bell curve because we will see that our data is skewed more to the left side than the right, for example. So box and whisker plots are great for understanding the shape of our data. And also, as in this case, they can help us understand the positional place of our data compared to other categories, right? Now, this is a wonderful graph, but of course, there are plenty more graphs to choose from. As we mentioned before, we have the trellis chart or small multiples, and this graph allows us to place simpler, easier to digest graphs in a matrix where we have different graphs representing different categories and different values. What this allows us to do is to break our graphs into simpler, easier to understand segments. So, for example, when we talked about the line graph that had many lines, if all those lines were relevant for our message, then we would be better off to break it down into a trellis chart or into a small multiples chart and display each line across the time frame for each category on its own tiny or smaller graph. And that will allow the viewer to make a comparison between all the different categories across all the different time values. We have the waterfall graph, and that typically shows us a starting point, and then it shows us the flow of data and increases and decreases over time. This is great if you're looking at, say, if you're comparing somebody's health score, right? And if that health score increased and then decreased and then increased again, and you're tracking it over time, at the end of that time, you can see where the increases were and where the decreases were, and then you can make a more informed assessment based on what this graph can represent. Sankey graphs. Sankeys show the flow of something from one place to another. This could be the flow of information, and this could be, say, the patient went out to get treatment at a private clinic and then return to the hospital. You can create a Sankey for all these patients and track their movement. Sankeys allow us to visualize where the data flows through and how it flows through and how that's interconnected. Tree maps are just great because they show in blocks of squares or rectangles by size the volume of data or the size of the data. So if we have values that are much greater, those will be in bigger blocks, and values that are much lower, those will be in smaller blocks, and they can help us visualize more easily the size of the data. Gantt charts are typically used for project timelines. Gantt charts help us stay on track on any project, and they shows our milestones and how our project can move from one milestone to the next, and what comes next within that project. Radar charts can show the relationship between different items within a whole. So you can have a patient 4 or 5 different diagnoses, and then you can track that by looking at the increase or decrease in these points in regards to the center. And if you have, let's say it increased a lot more on this side and then it decreased on this side, then you can tell how that patient's health is shifting. Butterfly charts are great for us to analyze typically data that is split in 2 categories. And butterfly charts are used a lot to compare males versus females. It could be on health status, it can be on height, it can be on any type of category, but it's typically the best way to make a comparison between 2 categories that are similar. Now, this is some extra credit information, right? So in order to create a better visualization, in order to present something that looks more informative, more professional, let's keep in mind some of these principles. Use sans-serif fonts for screen and use serif fonts for print. What does serif and sans-serif mean? Well, serif is this. Serif is a font that has tiny little elegant designs. If you see, the T had like tiny pointy things, the H had that little tiny pointy thing, the S has an N that expands. That is serif. And this is great for print. It's easier to read on print, it's just perfect. But for screen, this is just not that easy on the eyes. So for screen, it's always better to use sans-serif. Sans-serif means that there are no fancy elegant tips at the end of the letter. Every curve is just normal straight curve. There's nothing embellishing these letters, right? Again, use sans-serif fonts for screen and serif for print. Another extra credit point here. Incorporate your employer branding. This is a just made up logo. And so let's say you work for a healthcare company and this is their logo. When you create a presentation, when you create a visual, incorporate those colors. It is important for the company that everything that you present is uniform and consistent with the company. Keep that in mind when you present. Then lastly, avoid wide radiuses in background corners. This radius is right here, and I see this quite often. Actually, this radius is right here are something that was fashionable back in the 90s, back in the early 2000s. Now they have their place. This is a style. If you're creating a modern visualization, like an infographic with very cartoonish characters, with very bright colors, yeah, this is something that you can use. This right here is a style, but these radiuses are distracting. When you use this as a background in a graph, the balance from the placement of that graph to that corner is slightly more confusing, because now you have that balance from there to here and to here. Actually, we'll illustrate that here better. Now you have that here, and now you have that here, and now you have that here, and now this text is balanced against the curvature here. This is not good. Avoid it. For graphs, it's good and it's presentable to have semi-rounded corners if those are discrete, if your radiuses are soft, but not that soft. Everything else is a specific style. So for general use, avoid using wide radiuses. And with that, we have reached the end of our data visualization series. Hey, you made it all the way to the end. Thank you so much for watching. It's been a great experience for me to put this together, and I would love to hear what you think. So feel free to let me know your thoughts, your comment, your questions, and I'll see you on the next one.